Unit 9, Day 1 video notes, rational and irrational. Okay, we have two numbers here that we're going to compare. One of them a mixed numeral, one of them a improper fraction. And they're wanting to know whether the number on the left is less than, equal to, or greater than the number on the right. So we need to do two things here. First of all, we need to get them into the same form. We need to convert the mixed numeral into an improper fraction, and then we're going to need to get common denominators. So first of all, to convert our mixed numeral into an improper fraction, we'll take the whole number and put it over 1, multiply. So this is the same thing as, whoops, I need a pen. Same thing as 6 over 1 plus 2/3 equals 23 over 5. And then we will multiply this 6 over 1 top and bottom by 3 to make it 18 over 3 plus 2 over 3, so that we can now add these together. And let me go ahead and put in my equals 23 over 5, so that we can go on down and know what we have still. So now when I add them together, 18 plus 2 gives me 20. That's over 3 equals 23 over 5. Okay, now I'm going to, well, we can do the Venn diagram down below. Let's see, 3 is prime, 5 is prime. My Venn diagram, I have nothing to go in the overlap. There's nothing in common. So I've got a 3 here and a 5 here. So if I cover up this 3, what I need to get my common denominator is the 5. I still need the 5. So I'm going to multiply this fraction, top and bottom, by 5. And then the other fraction, if I cover up the 5, I still need the 3. So I will multiply it, top and bottom, by 3. Okay. And when I do that, 20 times 5 is going to give me 100, and that's over 15. And I wrote is equal to. I should go back and fix that. There shouldn't be an equal to there. We were trying to figure out whether it was equal to, greater than, or less than. So let me take it out here and move back up and take it out the other two places I put it in, because that's not or equal to. It's we're trying to figure out what it is. So let's just sort of put a box in here to indicate where our answer is going to go. So let's see here now. We'll put in that box to see what's going to go there. So over here on the other side now, 23 times 3 is going to give me 69. And that also is over 15. Now that we have common denominators, 100 is obviously greater than 69. So my answer is greater than. Okay, they want us to take this decimal and express it as a fraction in its simplest form. So first we're going to start with expressing it as a fraction, and then we'll take care of reducing it. So 100, this 0.125, it actually stands for 125 thousandths. But an easy way to do this, we're going to write 125 25 over, we're going to put a 1, and then there are 3 digits to the right of the decimal point. So I'm going to put in 3 zeros on the bottom of the fraction. The reason for that being that this 1, this is the tenths place. This 2 is the hundredths place. And this 5 is in the thousandths place. So this number is 125 thousandths, or 125 over 1,000. Now we need to reduce this. Let me gain myself a little bit of room here. And I'm going to rewrite it down here so I have room to play with. So 125 over 1,000. And I'm going to factor each of these. So 125. It's divisible by 5. And if I divide it by 5, I get 25. 5 being prime. Let's move back up here. And 25 is 5 times 5. Okay, how about 1,000? Well, let's see. 1,000 is 10 times 100. And that 10 will break down into 2 times 5, both of those being prime. And 100 will break down into 10 times 10. Okay, let me move down here. And each of those is 2 times 5. Okay, so now I need to take care of canceling, and this is going to be just a little bit of fun. Let's see if I can shrink it a little bit. That might be helpful. Zoom, and let's zoom to 75%, so that hopefully we can see the whole thing all at the same time. Let me extend the page a little bit, and then scroll, and now we can see the whole thing. So let's see what cancels here. Well, I've got a 5 here, and a 5 here, 5 here, and a 5 here, a 5 here, and a 5 here. So let's see here. On the top, everything canceled, so I'm left with a 1. On the bottom, the 5's all canceled, but I'm left with 2 times 2 times 2, which is 8. So my answer, in its fully reduced form, 125 thousandths, is 1/8, which happens to be a fraction that people who work with engines would know 125 thousandths of an inch is the same thing as 1/8 of an inch. And we deal with that fraction from time to time if you work with machining and rebuilding engines and stuff. Okay, find the indicated square root. Okay, and we've got a fraction inside the square root, and then we've got a negative sign outside of it. So the first thing we're going to do is we're going to leave this negative sign outside and figure out what the square root of this fraction is. Well, how do we do that? We find the square root of the top and the square root of the bottom. Okay, so to find the square root, and actually rather than dealing with that as a fraction, I'm going to separate these numbers and deal with each of them separately, because I think it might be confusing if I deal with it as a fraction. So we've got 81 that we're finding the square root of, and then we've got 1,600. So first, 81 is 9 times 9. And I'm going to go ahead and break it down even though I could do it from there. 9 is 3 times 3. Both of those are prime. And again, 9 is 3 times 3, both of them being prime. So, I've got a set of 3's here and a set of 3's here. The square root of 3 times 3 is 3, and the square root of this 3 times 3 is also 3. So the top of my fraction, the square root of 81, would be 3 times 3, which is 9. Now let's look at the bottom of the fraction. Okay, this is 16 times 100, 16 being 4 times 4, and 4 times 4 being 2 times 2, both prime. This 4 also being 2 times 2, also prime. And then 100 is 10 times 10. This 100 comes down, I'm going to run out of room here, it becomes 2 times 5, and this one also becomes 2 times 5. And what do you know, I got away with it. So that's prime, that's prime, that's prime, and that's prime. So let's see here. Well, this, okay, I've got a set of 2's here, and a set of 2's here, and then I've got a set of 2's there, and a set of 5's here. Okay, so let's see here. What do we have? This set of 2's, and yes, I changed colors. Hopefully it'll help us keep it separate from the other one. The square root of 2 times 2 is 2. The square root of 2 times 2 is 2. The square root of 2 times 2 is 2. And the square root of 5 times 5 is 5. So my square root is, for the bottom, my square root of 1,600 is 2 times 2 times 2 times 5. Well, let's see, 2 times 5 is 10, 5 times 10 is 20, and, 2 times 10 is 20, and 2 times 20 is 40, so the bottom of the fraction is 40. Now I have one more thing to deal with, and that is this negative sign, which changes the sign of the fraction, giving me negative 9 over 40. Okay, one more to deal with. What about when we need to simplify a square root? When we have one under the radical, under the square root symbol, that is not a perfect square. And maybe even have something outside of it. Now, when we have something out in front, it's a coefficient, just like when we have a coefficient of a variable. It's understood that what is happening right here is multiplication. This is 2 times the square root of 224. Now, we need to take this 224 and we need to factor it so that we can simplify it. We need to take any perfect squares out of it. So 224 is obviously divisible by 2. And when we divide it by 2, we get 112. Also obviously divisible by 2. When we divide that by 2, let's see, we get half of 110 would be 55. Half of 2 is 1. So 55 plus 1 is 56. also divisible by 2. When we divide that by 2, we get, let's see here, half of 50 is 25, half of 6 is 3, 25 plus 3 is 28, also divisible by 2. And 28 divided by 2 is 14. Extend the page, also divisible by 2. And 14 divided by 2 is 7. Now let me circle all of my primes here. Okay, so now what do I have here? I have a set of 2 2's here, another set of 2 2's there, and then I have a 2 and a 7 left over. So the square root of this is 2, the square root of this is 2, and then this 2 and 7 are going to remain inside of the radical, and I'll multiply them out. So let's see, what do we have? Well, we had a 2 right here, and we'll multiply it by this 2 and this 2 that came from finding the square root. So we've got 2 times 2 times 2, that's 8. So we have 8 times the square root of, and what's left in the radical? Well, it's this 2 times 7, which is 14.